Who reminded of recording?
Skriti.
But it should have been done by Ashlisha or Avdut. Okay, good. Anyone can interfere, no problem. So in surveying we have, as I was telling, trough compass, surveyor's compass, prismatic compass. These three main categories. Trough you have seen was there in the demonstration for the first lab, mainly used with plane table. Surveyor's compass and prismatic compass are what we use in the field, and in the present today's experiment we will go for. आपका screen shared है, Rakesh ji?
Yes.
Okay, so in today's lab we will use the chain surveying and chain-based traversing with the help of prismatic compass, and chains also engineering metric chains and non-metric chains. So we will use the metric chain whose length is either 20 meters or 30 meters with some links and tally marks in between the chains links, and which we will demonstrate in the small clip. And the use of the prismatic compass, how to set the instrument, how to take the readings. We have some video clips. So, Rakesh, you can take through the presentation. Yeah.
Okay. So, students, today I think I'm making it full screen. Screen is visible?
Visible.
Yeah. So, experiment number 2 is the survey and plot the given area by traversing. Traverse can be open and closed with chain and prismatic compass. Okay, this is our experiment number 2. Okay, so first we will go through some basics and some fundamentals. Then we will show a small video. We try to make it okay for the understanding purpose. So let me see how we can. Okay, so the introduction part, basically in surveying we usually measure horizontal linear distance between 2 points and angles between 2 lines. If I want to measure the linear distance, I will use the chain, and if angle, then we have to use some compass. So in this experiment we will use the prismatic compass. Okay, so there's a number of method is written here. Linear measurement of distance between 2 points on the Earth's surface can be carried out by several methods, okay, depending on the degree of accuracy and precision required. Okay, this is the important phenomena. So first of all, the chain surveying is the simplest method of surveying in which only linear measurements are made in the field. Okay, just keep in mind only we'll take the linear measurement. It's suitable for survey of smaller areas on open ground to obtain measurement for plotting exact description of boundaries of piece of land and for taking simple details. Okay. Now if the prismatic compass is invented in 1812. So the prismatic compass is more advanced type of compass with a prism. Why we call it a prismatic? Because in top of that there is a prism which enable a compass bearing to take while sighting our objective. So the traversing with chain surveying instrument and prismatic compass, the free or loose magnetic needle to determine the angle between the north direction and the survey lines. We'll have to find the graduation of fore bearing and back bearing. The last para you will explain, okay? So don't worry about it. So if I talk about chain survey instrument, so this is the chain, okay? Are you 1 minute? I think I have to. So this is the chain, okay? So this chain has some links, okay? If you see in this side of picture, if you see, this is have some brass handles, okay? And this has from this to this is 20 centimeter has this length, okay? This is the 20 centimeter. I can say list count of this chain, okay? This is mild steel chain, okay? Have some brass handles and have some tallies, okay? We will tell you at every 1 meter it has some tallies. Every 5 meters you see, every 1 meter, every 5 meter, every 10 meter it has some tallies, okay? So if we measuring that, then we can measure the links. Okay, this is the one link, 20 and again 20, again 20. So 5 links into 20 centimeter, then it will make a 1 meter. So for this way we measure the linear length. Okay, it's very easy. Okay, so we will explain. Okay, this is called chain. So if I want to do the chain survey, then again what we use for chain survey, we use the ranging rod. Okay, how you will use the ranging rod? Then this is this is called process called ranging. Okay, what we do by the ranging? Okay, suppose this is your station A. Try to understand. Okay, this is the station A and this is the station B. Okay, this is station A and station B. Okay, and the length of chain, okay, which I shown here, this is 30 meter. This is 30 meter. Okay, so sorry, so this is 30 meter. So suppose this is you are laying the chain here to here, okay, and here to here. So this is your 30 meter, the chain length one, this is 30 meter. Okay, so what you will do, you will put the one ranging rod here, one ranging rod here, and another ranging rod here. Okay, then what you will do, another chain you will put, okay, then another 30 meter, like 30 meter. So we should to see the direction of the survey line, your chain line should be straight. So what we can do, we can put another ranging rod here. So what is the meaning of that? The all ranging rods should be in one line. Are you getting or not? The all ranging rods should be in one line. All road must be in the same line. Because
is it clear? Is it clear to all of you?
Yes, sir.
Yes, sir.
Yes.
Okay. If there is
Yes.
something which you have doubts, please ask. Please.
yeah,
Stop.
please try. Yeah, you can interrupt me anytime, okay? Because it is very. So this is 30 meters. So what is the use of ranging rod? Our chain line should be straight or not. Okay, this is process is called ranging. Okay. Now what is the use of arrow? Suppose you had to measure the 100-meter length. So how much chain length you will use? 3 plus. Am I right? 30, 30. So 3 chains will be 90 and 10 meter. Am I right?
Yes.
Yes, sir.
Okay, so every 30 meter.
Yes, sir.
Every 30 meter I will put the arrow. Okay, every 30 meter I will put the arrow. So in the field, I can count the arrow and I can measure the how much chain that is I have used. Okay, another is wooden peg. As I said, if I started from A to B, so A or B is the fixed station. I think you have discussed in the class, these are my main station. Okay, so by fixing this wooden peg, the dimensions are given here, okay, 15 centimeter length. So my main station should be fixed by this wooden peg. Okay, suppose this is the area you want to see, this is A, this is B, this is C, this is D. So in A, B, C, D, I will fix the wooden peg here. Okay. Then I will see A to B, I will put the ranging rod here, here, it should be straight line. Okay. And another is the measuring tape. Okay. What we do, measuring tape, I will tell you, will take the offsets. Okay. Later on we will discuss. So before, if starting this survey, we should go to the field and we do the reconnaissance survey. Okay. We should do the reconnaissance survey. Why? There should be linear measurement, there should be no building. Okay, it means the entry visibility of the stations, the station A, B should be entry visible, B, C, C, D, A, D, B, D, the all are entry visible. Then we can perform this type of chain survey. Okay,
Is
so
it
this is
making
about
sense? The intervisibility of the points. Is it making sense to
Yes,
anyone of you? Okay.
Sir, could you please repeat that once again?
where-
Intervisible.
That's intervisibility.
what
Right,
we
points
do
A
when
and B are not intervisible. Yeah, you can tell offsets.
what we do when we start the survey, first we will see the area. Okay, if you fix the station A, B and C, suppose this is your imaginary stations, so you want to fix them, then it should be intervisible. If I standing at A, I should able to sight B. If I go to B, it should be A. I can sight the A. Likewise, B, C, C to D, and D to A, and B, D. It should be intervisible. Have you got my point?
Yes, sir.
Yeah. So these are the all. If I starting with the, if I'm doing the experiment with chain, so what are the instrument I'm using? Chain, ranging rod, used for ranging, arrow, wooden peg, and measuring tape. We will use for the offset. We will discuss.
All
Okay.
of you should please note down the instrument that are getting discussed, because these are the things which you will be needing to compile your records. So these are the components which we need for completing chain traversing. Anyone willing to ask something?
Sir, use of arrow.
Use of
Suppose
arrow.
what I said, if I'm measuring the 100 meter, okay. So my one chain has the length of 30 meter. Suppose this is the 100 meter, this length is 100 meter, okay. So how every 30 meter I'm fixing the one arrow. So what I can say that there will be 3 arrow. For 3 arrow means I have covered the 90 meter.
One full chain length
Yes, sir.
is from the beginning to an arrow. So from the next arrow to another arrow is another chain
because
length.
I have only the one chain now. Suppose you have measured from here to here. For next, so I will fix the arrow and then I will go to the next. So I will fix the chain arrow here. Then I will move ahead. I hope you are understanding.
Yes, sir.
Yeah. So I should go to next slide. So before we going to in details, there are some important definitions. See, here you see the main stations A, B, C, D, E. The all are the main stations. Okay, that all will be fixed by the pegs. Okay, suppose this is A. I will put a peg. I will fix it. And always remember this A station should be fixed by some reference point. Some reference point means the permanent reference point. Suppose it's X, Y, Z. Okay, I will fix this permanent stations, this A. Here, if I go B, suppose I will A dash, B dash, C dash. Why we are fixing with the permanent structure? It can be any tree, any corner of the building, okay, any electric pole. Why? Because if I want to repeat that survey or someone is going there, so he can use, he can locate where is our A and B, where is our main stations. Okay, then next is a main survey lines. The line joining the main station are called the main survey lines, like AB, BC, CD, DB, and DE. Then subsidiary and tie stations. What is written there? These stations are selected on main survey lines where it is necessary to locate the interior details. So now, if I want to locate the interior details inside this, because I enclose the area with the A, B, C, D, E, F. Okay, now I want to take the interior details. So what I will do, I will put some tie station like M and P. You see, you can see in the picture. Where is the M? M. Okay, this is N, this is P. So suppose here is the some building, so I can locate it. Okay, here's some garden, I can locate it. The interior details with the tie stations. Baseline, this is the very important line for the chain survey. This is the longest line which passes through the center of the field. Like AB, this is AB and CD. See, this is my baseline. The accuracy of the chain survey depends upon how accurately you measure this baseline. Why? Anybody can tell me? If you remember the class, can you tell me? The accuracy of this chain survey depends upon the baseline. Can you tell me?
One of you, please tell. Utkarsh Kumar, are you there? Utkarsh. You're not answering. You're not there. All of you, please remain alert and answer because these are getting recorded. So your answering
Sir,
will be
can I-
also.
Yes.
Who is it?
Sir, Saurabh Raj.
Saurav. Huh? Yeah. Tell.
Sir, as we are going whole to parts, so if we do an error in the first part itself, then that error will be transversed into the smaller parts as well. So that's why we should.
No, what is the reason? The baseline should be very accurately measured. I can tell you because there's a long PPT. Because you will make the triangles with the help of baseline.
Hey, who is speaking? Someone else is trying to answer.
Yeah. Please
Sir,
tell me.
Mohammed,
it covers large area. So, sir, it covers large area. So, if any error will be in this, so it will reflect in all the measurements.
No, that is fine. But you see, if you see this figure, with the help of baseline, you are able to make the triangle, na? For if you want to make this triangle, okay, so I'm using this baseline. If you want to make this triangle, again I'm using this baseline. So if your baseline is accurately measured, then it will limit your error. Are you getting my point?
Yes, sir.
Because everywhere if you make the triangles, because whole two part we are talking about, so you'll make the small triangles, so your baseline will be there every time. Okay, if you see this triangle again, this is your, you will use the baseline. Okay, so it's the longest distance, it is a longest line which passes approximately through center of the field. Some definitions called tie lines. What is tie lines? A line joins subsidiary or tie station to the main line. Okay, the main object of running tie line to take the details of nearby objects like D, R, E, F. You see D, capital D. Where is capital D? Can you locate? This is C. This is D. D, R. Now, more into detail, if you want to plot, then we can see this is my tie lines. So, the line joining the tie station becomes the tie line. Okay. Now, check line or proof line. A check line also termed as a proof line in a line joining the apex of a triangle to some fixed point or any two sides of a triangle. Okay. So a check line is measured to check the accuracy of the framework. The length of a check line is measured on the ground should agree with the length of a plan. So what is the meaning of chain line? Suppose if I say any line, okay, suppose this line DR. If I say DR is a tie line, I want to make it a check line. So what is the purpose of this check line? Okay, I will measure it. Okay, some distance will come. If I measure it, suppose it's coming 10 meter. Okay, so how can I use for this accuracy? It should, because ultimately what is our aim? All this data I have to prepare a map. So if I measure on the map this distance, because the map is made on some scale like 1 meter equal to 1 centimeter. Okay, on the map if I measure this dr distance, I should come on the field and I should measure again dr. It should match. Okay, are you getting my point? It's written all there. A check line is a measure to check the accuracy of the framework. The length of check line is measured on the ground. Okay, what you are measuring on the ground should agree with the length on the plan. This is our ultimate objective, to make the plan with the chain survey. Got it? Have you got this point?
Sir,
Anyone
can you
having
explain
doubts?
once?
Okay.
Yeah, tell me, where is the problem? Yeah, please.
Sir, from the part, ground should agree with its length on the plan.
Listen, why we are doing this exercise? See, if I'm making this all in the ground, so whatever I'm doing the exercise to measuring this main station, chain lines, I should prepare a map. यहाँ तक clear है?
Yes, sir.
Okay, so in map, suppose I'm measuring this distance dr. In map, you are measuring this distance. Your map have some scale. Is it clear?
Yes, sir.
Okay, so in map you will get some distance. Now that distance should match with your ground. So you will go in the ground, again you will check, okay, it is matching or not. Is it clear?
Yes, sir.
Okay. Now, next thing is offsets. Okay, these are the lateral measurement from the baseline to fix the position of the different objects of the work with respect to the baseline. These are the generally set at right angle offset. Okay. Now, what I have said, you this tape will use to make to measure the offsets. Now, if you see here, suppose if you are going with this chain line, okay, DB. Okay, now either side of this chain line you have some permanent structure. Suppose this is the one building, some tree is there, some pole is there. So what we will do, we can take the perpendicular offset or oblique offset. Suppose this distance, I'm starting from here, this is suppose at 5 meter I got some tree. Okay, at 10 meter I got some another tree. Okay, and 15.2 meter I got some electric pole. So either side here I can get a one garden. So the lateral places I have to mark, like what is written, to fix the position of the different object of the work with respect to the baseline or main line. Okay, so in survey, what is the use of offsets? Can you tell me?
Yes,
The
one of you please
details.
tell. One of you please tell the use of offsets. Himanshu Ranjan. Himanshu, can you tell?
Sir, offsets are used to locate the surrounding structures.
Yeah.
We take measurement using tape. That's what we sir told right now.
And then types of offsets, what is the utility, anything?
Yes, sir. As I told, to locate the surrounding structures in the map.
No, I am asking types of offsets. Sir has also told two different types of offsets.
So the sir was talking about perpendicular measurement.
Very
Okay,
good.
so there is a perpendicular. See this picture. Okay, if this is your main survey line A and B, if this is the one corner of the building, so these are the right angles. So we are saying the perpendicular offsets, and I can take also the oblique offsets. Then I have to take two measurements on the my chain line. So you can easily see which one is more accurate. Can you tell me? Out of these two, perpendicular and oblique. Huh?
Sir,
Oblique.
Yes, very good. So oblique offsets are more accurate because we are taking the two measurements for that. The measurement taken at right angles, that is called perpendicular, which are not made at the right angles, so we call the oblique offsets. It is very simple. Okay. So what we do in the survey, it I told you in the beginning, we do the reconnaissance survey. The primarily inspection of the area to be surveyed, the surveyor inspect the area to be surveyed, prepare a hand sketch called the index sketch or key plan. Okay, the key plan is drawn on the field book. Okay, first you make the index sketch roughly by hand. Okay, now marking the main survey station by wooden peg, that is already told to you. After fixing the station, ranging is done. For intermediate station, tie station with help of ranging rod. Length will be measured by chain and offset will be taken wherever permanent object will come. All record will be details, measurement information will be recorded in the field book. See, in this field book, this is your station. Suppose this is A and this is point B. So the station is marked like this triangle A, and this is B. Okay, so I am going in this way. Suppose you are going in this direction. So at 5 meter, you're okay. This is river. Okay, this side, this is a river. So I want to locate the river position. Okay, so at 5 meter, I will take this offset here. This is some 13 meter. Okay, then I'm going this 25 meter. I will again measure the offset. Then at 40 meter, I'm again taking the offset. 80 meter, I'm again taking the offset. So I can draw this line of the river. Okay, if you see, if I want to locate the pond, so at different points of the pond, I will take the offsets. So easily we can locate the either side objects. Okay, this is the simple. So this is, so what will happen later on, A, B, and the next page will come C, D. The same structure will come. Again, you will make the lines. Always there is a one way to show the main station. We will make the triangle and put some dot to fix the stations to show on the field book. There is a way to how to write in the field book. Okay, that's why field book is required. Okay, now all the details you will go in the office and your hostel, whatever, draw the details on the drawing sheet on the suitable scale. Okay, this is ultimately our objective. If I will send you one ground, so we have to plot it and plot on the drawing sheet. So anybody can use, okay? Then we don't want to go in the field. Anybody can use this drawing sheet to see what are there on the field. Okay, this is about chain. So if any doubt so far, let me know. Then I will introduce prismatic compass.
Yes, anyone having any doubts? So first is you will go for reconnaissance survey. Based on that, you will plan for.
Do we have to buy field book?
Yes.
Do we have to buy field book for online lab?
If you are getting, you can, because it will be a good experience to how to record the data in the field book. It will be good if you able to find it.
You are in campus?
Yes, sir, but tech market is closed, I think.
Tech market is open, you are closed in the hostel.
Okay. No, they can come out, I think, after some pass or something like that. But it's good to have the field book for survey lab. Okay.
No, they can get the field book. This week only the tech market is restricted, but next week onwards they may get.
Yeah, absolutely.
Whatever is getting discussed, all of you should write down on the field book. So what are the instrument that you have written? One of you please tell. Jai Kumar Soni, can you tell what are the things needed for carrying out chain survey, chain traverse? Jai Kumar Soni. Jai Kumar Soni is not, Dabil chala gaya. Okay, Kuldeep. Kuldeep, you are there? Am I not audible, Kuldeep? What's happening?
So इनका नाम लिख लेते हैं, absent कर देते हैं इन सबको.
हाँ नहीं हाँ वो तो मैं बोल दिया. This is there in the recorded also form. They should be alert because they are not answering means they are not there in the class. That's there.
Sir, can I answer?
No, Mohammed, you wait. Will come. Nancy, you tell.
Yes, sir.
Tell.
For chain survey, we need ranging, firstly chain, then ranging rod, arrow, wooden peg, and measuring tape.
Very good. Okay. Yeah. It's not just a chain, it's an engineering metric chain. Okay. Engineering.
Yes, sir. Okay, sir.
Good. Okay. Yeah. So anyone having any more doubts until now? Okay. So where do we put the?
Excuse me, sir.
Who is it?
Sir, I'm Divya Shri.
Yeah, please tell.
I couldn't understand how do we use ranging rod for making the so that the chain is like straight. The measurement is.
It's not just for aligning the chain. It's aligning the whole path along which you will lay the chain to measure the distance. So between points A and B, which is more than 3 chain lengths. So it is 100 meters, suppose, as was being discussed. So we need to measure the length between points A and B along a straight path. So there should not be any deviations. So to make it aligned and make it adjusted to the length of the chain, we use the ranging rods intermittently so that these intermittent portions are together making a linear shape with the endpoints A and B. Is it making sense? No. So at two ends, there will be two of you. Like once the experiment is done, if it is videoed properly, you can see two ends, two students will be standing, and intermittently with ranging rod, two more, three more will come, and they need to be signaled properly to get aligned at the tip of the ranging rod on ground. Okay, so there is a procedure to hold the ranging rod, there is a signaling structure, but two endpoints are fixed. Only the intermittent locations where three more ranging rods are to be located are to be adjusted to make them fall on the path AB, straight path. So once they are aligned, so intermittent locations are also fixed, you take the linear measurements using chain. This is probably what I told as a story, but what was shown in the picture on the first and second slide, I think, Prashrakesh, can you go to that figure? This one, see, yeah. So one person is here in the first ranging rod, then another two, and third one will also be another person who are facing each other. The intermittent two are to be held by two more who are not falling on the line of sight between the first and the last. And those two intermittent points, those locations need to be adjusted so that they fall in the line joining the extreme points. So that's the ranging operation. Is it making sense? Is it clear?
Yes, sir.
Okay. This operation is known as ranging. And can anyone tell where we use the wooden pegs? Where to use the wooden pegs?
Main station.
Main stations.
For what? Good, main station.
To fix the mains, to fix the point means.
Yeah, so fix
the points
station.
on baseline.
No, to fix the point or mark the point on the ground corresponding to the instrument station. Okay. So next time you want to repeat, you don't need to again search for where was the last instrument station. So the wooden peg is there, go center and get the instrument set and ready for taking the data. Okay. Okay. Any more doubts? So if none, then we can take to the prismatic compass. Is it okay?
Sir, could you once more explain that how we ensure that straight line between point A and B?
Okay. I think I should make a picture. Then it will be clear.
Make a drawing कीजिए.
1 minute. So, I think you're able to see this white slide.
Yes, sir.
Yes, sir.
Good. This is your point A. This is your point B. Okay. This is your main station. Okay. Now, suppose this length is 100 meter. Okay. So I have given you chain. This has the length of 30 meter. Am I right?
Yes.
Yes, sir.
Okay. So first you will start, and the least count is 20 centimeters. Okay. We measure by the link. So here to here, you will put one chain. This is the chain number 1. Then what you will do? your chain number 2. Okay. Am I right?
Yes.
So how you know your chain is going straight? It can be like, it can be, suppose you A and B. So A and B should be in one line. How you know? Okay, if I say one your leader is here in survey term, one is called leader, another is called follower. Okay, so leader is here A and B is here. So it can be a problematic if you can be standing here. So how to make this is in the one line? So that's why what we do, we put some ranging rod here, here. So the A and B direct each other to move little bit left, little bit right, either side. So you will get a one position. Again, here is the ranging rod, here will be the ranging rod. So this all 4 ranging rods should be in one line. So I can say I'm still able to locate where is my B. It should be in one line. Are you getting? I think.
Sir, but the doubt is how we ensure that before making the straight line between A and B, how we ensure that in which at which position we have to place the second ranging rod.
Okay,
Anywhere,
that
anywhere,
is
no
through
problem.
your viewing. You should view from your ranging rod to the last ranging rod B, and all should be on the same line. So there should not be any deviation.
A student is asking where we should put this ranging rod, na? Yeah. What was this one? Where I should put here?
Try to explain through this.
So means one person will be standing at point A and another will be standing at other will be holding the rod, and A will ensure that the second person is holding the rod in the right position.
Look. The positions of A and B, and with 2 of you holding the ranging rods is fixed. You should hold it vertically.
This is A and B fixed.
Now the intermittent ranging rods, their locations are to be decided, and that is decided through your eyes view. So you first place one of them. See that A, B, and 1 are in straight line through your visual inspection, through eyesight. If it is not falling on the line between joining A and B, you can move one either left or right of the line to be placed by the holder, so that A, B, and this first one comes in line. And then once these 3 are in line, the next ranging rod can be introduced at position B 2, so that A, 1, B, and 2 are in straight line by visually looking through A to B. Is it making sense?
Yes, sir. It means it requires at least 2 person
to
do this.
2,
yes,
3.
not
I will
2,
say 3. 3.
4 persons.
Minimum 3.
Minimum 3-4
Minimum
persons.
3. Minimum 3. Okay.
Okay, sir.
So that's how survey lab cannot be done by a single person. So you need a group, and that's why we used to have a practice of putting a group of
Leader
6 students with the leader and deputy leader for each group. Okay. Now that you are missing all that, but conceptually probably you have now understood the concept of ranging. Is there any more doubt? Okay, so Kuldeep, are you there? Can you answer? Is it okay? Kuldeep is finding, not responding. Vasnik? Lohitya Vasnik? Why you are not responding? You are not following, or you are not there in front of your computer? You are absent that way? Yeah, Mohammed, you wanted to say something. Yeah.
Sir, which Mohammed?
Oh, which Mohammed? I don't know. Mohammed. One is.
I guess Han.
Sir, when
Anand.
you were asking question, then I said that, sir, can I
Achha.
answer?
Yeah.
Then you.
Anand. Okay. Okay. Good. Good. So, but this ranging is clear. So, Anand.
Yes.
Yes, sir.
Okay. And
Yes.
Tausif, it's clear to you? Tausif?
Yes, sir.
Okay. So we can move to the next part. Yeah. This Rakesh.
Now, prismatic compass. So what is the role of prismatic compass? Okay. Now I will tell you the parts of the prismatic compass. Okay. So the prismatic compass, we have to see the angle bit from how to make you understand. Suppose this is your north. Okay. What is the use of this magnetic prismatic compass? There is some magnetic needle. You see there is a north is written here. Okay, it will show you the magnetic north. Okay, now suppose your survey line is this is A, this is B. So what is the angle between this, the horizontal angle between these two? Okay, this is called bearing. Okay, magnetic bearing. In survey term, I will say this is magnetic bearing. If I say this is 30°. Okay, so the magnetic bearing of line AB is 30°. It means it is making angle 30° from the magnetic north. Okay, this is the use of this prismatic compass. So if you see system of graduation in this graduated scale, so this is north, south, east, west, and it's very interesting to know here the 0 is marked at south side. Okay, it makes sense. Okay, I will ask you why it is so. Okay, so keep remember, if you see through this eye slit, your south is marked at 0. Okay, and if you are suppose if you are sighting the north, then what is rotating? The outer circle. The outer circle of this prismatic compass will rotate. Your needle will be remain there. Okay, then you can measure this AB. Okay, so this is the graduation system. At north it will be 180°. So these are the some part. Okay, when we open it, and this is the prismatic compass with the tripod. Okay, now I quickly, if I go in the parts, if you see here, so if I am seeing from here, so here it will be the south, here will be the north. Okay, so I will see through here. What is the number 9? I will see from 9. 9 is your eye vein. I will see from the eye vein. So the reading will be seen here. Okay, now here will be the some ranging rod. Okay, some ranging rod I will bisect. Okay, by the help of what is written 6 or 5. 6 is your horsehair. Okay, what is your 5? Your silt metal frame. So your horsehair should bisect this ranging rod. Okay, so as I shown you in the last, so your ranging rod will at B will be your ranging rod. Okay, so it will bisect by this horsehair. Okay, in video I will show you. Okay, where it is. Okay, so I can measure the angle from the magnetic north. Okay, what are the different parts? This is called pivot. This magnetic needle is suspended through it, and this 18 is your support to fit on the tripod, lifting lever. This is called brake pin or knob. When I take the reading 16 number, I should press it. So our magnetic needle will be fixed. So I can take the readings. Okay, so if you see the 11 number, here is the dark sunglasses. If there is a sunlight is there, I can adjust them. So there is a very handy instrument. We can use it. And what is the least count of this instrument? Is called 30 minute. Please remember. Okay, 30 minute is the least count of the prismatic compass. Okay, now you see. Okay, I can use with the hand. Okay, to see the manually, and I can fix on the tripod. So see the person is taking the reading on the tripod. Okay, so as I told you, the bearing, if I define the bearing, is the horizontal angle between the reference meridian and the survey line. What is the reference meridian? The north line to AB. So this angle is called the bearing. This is the horizontal angle. Always remember. Now type of bearing, this is called magnetic bearing, as I told you. Okay, true bearing, magnetic bearing, if you're taking from the magnetic north, if I talking about the true bearing, it is called also azimuth. Okay, so this is the true geographical north. If I measure the reading from true geographical north, then I will say true bearing. Otherwise, if I'm using this prismatic compass, I have to say this is the magnetic bearing. So again, we will discuss in the class, theory class. Okay, then on this, if you see this, so it will start from 0 to 270, again 360. Again it will be 0, again 360 will also be here. Okay, it is not written, 0 means 360. Okay, so the reading will come in the magnetic bearing ranges from 0 to 360 degree. Okay, the angle made by a survey line in clockwise direction with reference to magnetic north and south. Okay, the value of magnetic bearing ranges from 0 to 360 degree. Okay, so there is the arbitrary bearing. It is the horizontal angle which a survey line is made with a arbitrary meridian. Okay, in field for the small survey I can make any line. Okay, I can make it a arbitrary meridian which is the convenient direction towards a permanent and prominent mark or signal, such as a church spire, top of chimney. Okay, such bearing are used to determine the relative position of a line on a small area. What we do in the small area, any line I can use as a arbitrary bearing. Okay, so this is, we'll discuss again in theory. Okay, then if I am using this prismatic compass, so there is a concept of whole circle bearing and radius bearing. The complete circle of angular measurement starts with north as 0 and ends with the north 360 degree. The bearing of line directly obtained by magnetic needle ranging from 0 to 360 degrees called whole circle bearing. See, if I'm measuring, this is my north, okay, and if I say I'm measuring here, so this is my A, B, this is, if I say this is C, this angle, then again I will take this angle. So in clockwise direction, I'm making the measurement between 0 to 360 degree. Then I'm taking the whole circle bearing. If I talk about the reduced bearing, then if you see this figure, if I say this angle is alpha, so then I will say the reduced bearing will be an alpha E. I'm using the quadrants. So there is a 4 quadrants, 1, 2, 3rd and 4th. So the line here will be the OA line bearing. OA reduced bearing will be, what will be? An alpha E, because towards the direction of east. Now about OB, then it will, the reduced bearing will be, can you tell me, as this angle beta towards E. Like, so we are using every time this north and south in the reduced bearing. So the more convenient way to comprehend the direction of the survey line to represent the bearing on a quadrantal system. The angle is measured with respect to north and south line. Suppose, for example, if you want to measure OD, anybody can tell me what will be the reduced bearing? Can I write? It will start from an or as. So I will say an, this delta, this is W. This is the reduced bearing of this line. Are you getting this point?
Yes, sir.
Yeah.
Yes,
So
sir.
we can interchange. Okay. Sometimes we have to play with the whole circle bearing and reduced bearing. We can always interchange in between them. Now, what is the concept between, if I say fore bearing and back bearing? Suppose this is your station A and this is your station B and this is your north. I'm measuring the north with the prismatic compass and from here I'm sighting the B. So this angle will be some theta. So this theta will be called the fore bearing. It is the direction of the survey line. It means A to B, if I'm taking the reading, it's called the fore bearing. If I'm putting the instrument at B and again I'm sighting the A, okay, then it was called the back bearing. It means BA. Okay, so the fore bearing is written the survey line from the starting survey station to the next station is called the fore bearing. It means the direction of the surveying. I'm going A to B. It means it is a fore bearing. If I say back bearing means taken from the forward survey station to preceding station. It means B to A. So then what will be the theta 1? from north to this line. I hope you are getting this point. Again, I'm making here A, B, this line. So if I say this is my north, so for AB, it will be the angle theta. I will put the station, put the prismatic compass at B. Again, I will see this. So this is again my north. So this will be my theta 1. So your theta will be the fore bearing, or theta 1 will be back bearing of this AB. Have you got the point?
Sir, but if we do like 360 minus theta, so will we call that back bearing? Or
No,
not?
no. You can do that one, but have to measure with the prismatic compass.
So, but like since you said like if we go from A to B, then theta is fore bearing. But
Yeah.
can we call that 360 minais theta that
No,
back bearing?
You check the diagram.
360 by theta कैसे आएगा बताइए?
हाँ,
Then ये angle आ जाएगा.
ऐसा नहीं, दूसरा आएगा.
Then this angle will come ना? I want this angle.
So, but when we are measuring from B, then also that is only.
No,
If I'm measuring with the
diagram.
It should be 180 plus theta.
Yes. So the difference between fore bearing and back bearing is always 180 degree if there is no local attraction. We will define what is local attraction. Are you getting that? The difference between, if there is no error between back bearing and fore bearing, then the difference will be 180. Have you got the point? I think, is it clear?
Yes, sir.
Yeah. So if the difference is not 180 means, suppose what I said in the beginning, your prismatic compass have the magnetic needle. So suppose if it is magnet, if there is a magnetic substance are there, some iron or something is there, okay, at B. So what will happen? It will not give the correct reading. Okay, some current is passing, some high tension line is passing through station B. So what will happen? This magnetic line will be not settled down. So it will give the incorrect reading. So that time what will happen? The difference between fore bearing minus back bearing will not be 180 degree. Am I right? Is it so?
So I did not understand like how it is 180 and not 180.
Listen, let me explain. If I'm measuring from A to B, I said this is theta. This is called fore bearing. If I'm measuring from B to A, my prismatic compass at B, so I'm saying this theta 1, then it is called back bearing. So if both the station is from the error free, okay, if there is no error, where can be the error? It can be instrumental error, it can be human error, and precisely if there is a magnetic substance are nearby. So what will happen? This is a magnetic needle. The iron presses are there. Okay, some high tension line is going through ground. So what will happen? This will not give the exact reading. Okay, suppose this reading is not 30 degree. Okay, it will oscillate. Reading will be fluctuate. Are you agree?
Yes, sir.
So at that time what will happen? This fore bearing minus back bearing will not come 180 degree. Is it so?
Yes, sir.
Okay, so that we have to find. Okay, so always remember when we do this type of prismatic compass we are using, so it should be free from this system. That's why we do the recurrence survey. Okay, first we see in the field. Okay, if we cannot remove it, then we by calculation. Okay, when we solve the numerical, we will remove it. How to remove this local attraction? Okay, there is some way to remove it that we will discuss. So this is the concept of fore bearing and back bearing. Now, as our aim is to make the traverse with chain and prismatic. So what we will use the instrument, I think all are clear. Okay, I think you don't understand the plumb bob. Plumb bob to suppose see, if I talk about the plumb bob, so we will hang some plumb bob. Okay, from here to mark the center of the instrument. So now objective, I think it is clear. You have to, with chain, you will measure the length. Chain is used for measuring the length, prismatic compass for the bearing. then you will find out the bearing error, then you will say in which station we suspect the local attraction, and based on all the available data we can prepare a map. You can also use the suitable software for that one. Now again, if I quickly go through the procedure, so we will fix the prismatic compass on the tripod. Compass card should not be touched on the compass body or any kind of tilted. Make the centering of the tripod. What is your needle? The magnetic needle should be freely suspended. Okay, it should not touch. Okay, it should not tilted. Mark the centering of the tripod with the help of plumb bob and mark the first station. Then the compass is required to be leveled, so the aluminum ring is to be horizontal plane, hence to free to rotate on pivot. Okay, once again I can tell you. See, here is the pivot. There is a magnetic needle, so it's free to move. Okay, if it will touch any side, if you make it tilt, so it will not free to rotate. Okay, then once the compass is centered over the station, the process of taking the reading. So let's A B. So I will take the fore bearing and back bearing. This is the system we have to do at every station. Okay, so I think this is all written what I have told you. The compass is turned so that the sight is aligned in the direction of AB by making eye slit. This is eye slit marked is there on the prismatic compass of observation vane, vertical hair of the object vane, and ranging rod at B. I have to see the ranging rod at B. Okay, we wait for the oscillation of graduation ring to dampen. Your magnetic needle should not oscillate at the time of taking the reading. So we use the brake pin. Brake pin hold the ring, hold the your magnetic needle. Okay. So the viewing prism is focused by moving it vertically with the help of focusing stud. Okay, when you will do the experiment, then you will able to see the reading. Okay, some adjustment you have to do. Okay, with the help of focusing stud. So the reading of image of hairline is observed through prism is noted, indicating the whole circle bearing. So first this instrument will give the whole circle bearing. Later on we can convert in the reduced bearing. Okay, the process is repeated for the better measurement. This is called the fore bearing. Then come to point B. Then again you will take the back bearing. This is all written what I have told you. Then you have to repeat for all the stations. Like in the next picture. Okay, if you see here A, B, C, D. So first I will put the prismatic compass here. Remember, we will measure the length with the chain and the angle with the prismatic compass. So first I will put here A. So I will make this angle. If I here is measuring A to B. Okay. Then what is happening? Then I will come to this B. Then again I will measure this angle B. Okay, we try to make it so you can understand. So then again I will from this station I will measure this, so this BC. Okay, then again it will be the I'm measuring the back bearing CB. Okay, so likewise we can do all the stuff. Okay, so what I want to say here, suppose for line bearing A, B, B, C, D, these all are given. The fore bearing and back bearing is given. So what is your work? You have to find the error. Okay, where is the local attraction is there? Okay, and if there is any local attraction is there, then you have to divide in all the remaining A, B, C, D in all the lines. Suppose your how to find if there is a difference between fore bearing and back bearing. Can you quickly tell me where is the difference is not 180 degree? There will be one line. The difference will be not 180 degree. Which one is that? Can you tell me? For line AB, what is the difference? Can you tell me? Anyone?
Sir, in AB, the difference is not 180 degree.
Not 180 degree, confirm?
Yes, sir.
Yes, sir.
What about BC? Is it 180?
No, sir.
No. So 2 lines are measured with the have there some error. Okay. Then what about CD?
No, sir.
CD भी नहीं है. DA.
No, sir.
So all the bearing don't have any. So at least one should be 180 degree. If it is not, then you have to make by forcefully
Sir,
you have to
AB
make.
has, sir, AB is 180
Yes,
degrees.
sir. AB has 180 degrees.
क्या यार तुम लोग कैलकुलेशन भी गलत कर रहे हो. I am just believing on you.
Sir, AB has 180, rest don't have.
Yeah. So AB have. So we will start from AB. It means we will assume that our AB is the correct line. Based on that, we will correct all other B, C, C, D, and D, A. We will discuss how to do it. Okay. So this is one numerical problem. Okay. So now, any doubt so far you can ask. We will show some video.
Yeah. Any doubt from anyone about the?
So this is your task to today. Find out the bearing error in which you suspect the local attraction. Suppose following bearing is given. Okay. How to solve you will discuss in the class. Okay, not here. So let me know what you understand.
You please go to the procedure portion.
Yeah.
Yeah. Is there any doubt that any one of you have regarding the procedure for carrying out this experiment, this part of the experiment? Amardeep.
Yes, sir.
Is the procedure clear?
Yes, sir. All clear.
How do you ensure that the prismatic compass is properly leveled? Amardeep? Am I audible, Amardeep?
Yes, sir. Sir, by using spirit level.
Where to use? We have never told any spirit level to be used. Spirit level can be used, but we have not told yet. Otherwise, without spirit level? Anyone who can tell? Aniket Kumar Gupta. Aniket?
Yes, sir.
Tell.
Spirit level.
Other than spirit level, any method to know that it is properly leveled?
Sir, is it this first line that compass card should not be touched?
Yes. The compass, the measuring circle reading should not touch the upper and lower surfaces inside the instrument. So it should be free to flow, float. Okay. Okay, good. And anyone else has any other queries? If no, then we can have a small video recorded session which is made for you to understand the chaining, offsetting, and handling of the prismatic compass. Is it correct, Rakesh?
Sir?
They can, in the video, they can have an understanding of how to handle the chain, take offsets, and handle the prismatic compass.
So we have make one video we tried. Okay, so let's see how it can help you.
So, Professor Rakesh and Professor DC, actually this video is ongoing and that won't get saved if it is too long. So we may stop it and then continue with this video because this we are again.
Stop the recording.
Yes. That will be.
So it is visible?
Yeah.
Yes, sir.
Yeah, try to understand, okay? Then you ask me the questions. First you see. So this is 1 meter, okay?
Yeah, this is 5 meter, right? Down level. This 2 number of notch means 10 meter. This is 15 meter, right?
Yeah, so still we have done the details of the chain. Am I audible to students?
Yes, sir.
Yeah.
Yes.
So what you have seen, the ends is the 2 brass handles. Okay. List count is 20 centimeters. So as we have shown you, the tail is at 1 meter, 5 meter, 15 meter, in between is 10 meter. So these are some tallies. Okay. We can quickly find where is the 10 meter. Okay, so this is about the detail of the chain. Now the next will come the fixing of the main station. So we are only showing to the A and B only one line. Okay, how to fix the station A, main station. Please you see this. Okay, so this is station A. We are making fixing. Okay, this is the one measurement. We want minimum 3. So this is the from the tree we are fixing, and here we are taking the another. We are taking some another tree to fix it. Fixing the station A. It is our main station. Okay, this is only for the demonstration purpose. We want to make you see how you have to do it. This is the pole. This is we are taking the offset along the chain. So in either side there will be some, this side there is some fixed point. Okay, it should be on the ground. Okay, we should take on the ground. Now we are taking the offsets of some tree. Where is the location of the tree? Okay, these all are taking the perpendicular offsets. We're not showing you any oblique. Okay. See, again we are taking the offsets. It should be 90 degree. Now you see, again we are fixing the second main station, that is our B, as I told you in the beginning. Again you will take the 3 measurement to fix it. So now we will demonstrate the prismatic compass. So see, this is our tripod and we are fixing the prismatic compass on the tripod. Okay, I'm just pausing it. So see, this is called a horsehair. Okay, and this is the magnetic needle. Okay, and we have to see the reading from this side, side van. Okay, so the prism you have to see the reading. Okay, on this scale on here. Okay, so now if you want to see, you see. Okay, from this side we have to see the reading. See, from here you will see the reading. Okay, and this is that side is the horsehair that will bisect with the your ranging rod. Just try to feel it. Okay. North side there is a 180. If you see the reading on the top, it will be inverted. Okay, the readings if you see the inverted, but through the prism you will see the correct reading. This is south. At south will be 0, and at that side, the north, where is the north is written, that is our 180. See. Now see, we are bisecting the ranging rod. Okay, so some reading will come and you will write on the field book. Now again we will bisect the second ranging rod. So it will give the magnetic bearing between these two lines. You see, only the outer ring rotates, not your this magnetic needle. Okay, so please ask any doubt. Feel free to ask.
Sir, what's the use of that prism? What it does in the compass?
The prism is, if you see in the video, again I have to open it. Okay, from slides I will able to make you.
Let me tell. The prism is mainly for facilitating the observations.
See here.
The observation.
See here is the prism. Okay, if you see the 8 number, na? 8 number reflecting prism with cap. So by prism we are able to see the readings that is graduated on the ring. Okay, here is the prism, na? By prism we are able to read the reading.
Sir, so it is just for ease in reading, like other.
Okay. Yes. Anyone else?
Excuse me, sir.
Yeah.
So while measuring the 4 bearing, we do it with respect to the north direction.
Yes.
And in the compass, the north direction is marked as 180 and the south is marked as 0. Why is it so?
Yeah. Anyone can tell me? This is the magnetic north. This is the very interesting question. Who can give the answer about this? This is the very rightly asked the question. At south it is marked 0.
Actually, magnetic north will be attracted by south pole of Earth.
Yes. So
so we are indicating a 180 degree at that point.
Sir, may I?
Yeah, please.
Sir, because now if we will see the reading from the prism, it will directly give us the right angle. We don't need to do any calculation.
It will give the bearing, magnetic bearing.
Yes, sir. Means if here it is 0, so whatever shift will be in the angle, we will directly get the angle under the prism. But if north would have been here at the position of, at 0 degree, then we will be required to do some subtraction.
Okay, anything else? Anyone? Who was the first? Who was taking that side, the North Pole? Who was that fellow?
Is it related to like the North Pole we took as 0 degree, and basically the magnetic north is actually the geographical south. So
Yes. That's why we have make it reverse. Okay. Have you got the answer? Otherwise, I have to explain.
So, the bearing we calculate will be with respect to geographical north, right?
Yes.
Okay. Thank you.
Anyone? Good. Professor DC is there. Kamlesh ji?
Yes, yes.
You want to add something, please?
That was so good. You can stop sharing then.
Yeah, stop sharing. I should stop sharing. Yeah.
With the demonstration now video mode, we have seen probably how to lay the chain out, how to take the offsets, how to set the prismatic compass, how to record the readings. Everything is clear to all of you students? Anyone having any further doubts? What we are not having in hand is a real life feel, and you don't have, probably all of you don't have the lab record books yet. So, and the data what we have collected, our mining engineering department, around the mining engineering department, we go for traversing, getting the offsets. So what we planned is we have the earlier field record books. There's some snapshots of that will be shared with you until the lockdown is over. So most probably by Monday we will upload the field record book pages which have been recovered from the last year or last to last year's students, and then it will be shared. So we will be expecting you to analyze those and generate the plans, AutoCAD, whatever tool you are confident of. So it will be around the mining engineering department, some closed paths, main building or an extension of main building and our rock mechanics workshop area. So those 2-3 traverse paths were earlier designated. So we will see what all data are there. So accordingly we will upload and assign roll number wise groups to come up with your plans, and you write the procedures as discussed. So based on, of course, one table is with us, the prismatic compass is with us. So with that, you analyze the data and come up with the understanding of distribution of errors. And if some precautions which you feel need to be taken during both the chaining as well as prismatic compass measurement, base measurement, you need to write it in your lab requirement.
So if any question, please ask. I think there's a lot of confusion should be there because we are not performing with hands. Okay, please ask. We'll try to.
What did you say about AutoCAD software?
Once, yeah, Professor DC, continue.
Now, what is the doubt with AutoCAD software?
What we have to do in AutoCAD software? Can you repeat that part?
Yeah, so these are the records of field book. Okay, so field book which should have been yours, but the field books of your senior. We'll put it on this team by Monday evening if things work out well. So then based on those readings, you need to understand them. They have taken offsets that is there. So once those data are available with you, using any of the CAD tools, either some of you are very good in AutoCAD, others may not be. Someone else uses other CAD tools. So using those, you have to prepare the plan of the traversed area, and this plan is along some paths available in the mining engineering department. So by now you must have visited the mining engineering department, all of you, isn't it? Anybody who got chance? No. Okay.
So only seen from outside.
Yeah, only seen it from outside. On the video, there was the survey lab at the background. So, yeah, so we carry out the survey lab in the outside the lab in the premises of our mining engineering building. So, around that building, the traverse records for a closed traverse will be shared, and those data will be asked to be understood, read, and converted to a particular drawing. So it can be drawn using any of the CAD tools. This is the task. Is it clear? AutoCAD is not essential, but any CAD tool.
So if there is no doubt, can I ask one question to all of you?
Sir, I have a question.
Yeah.
Sir, like north shows 180 degree, and if you are watching any observation point, let's say it shows, it'll show 150 degrees, then we will have to subtract that, right, sir?
No, listen. Your prismatic compass will give you the exact reading, okay? 150 degree from the north. Okay, because you are reading the reading from the south side. Where is your prism? Okay. Again, I have to share 1 minute. If you see the PPT, see, where is the 0? Can you tell me? Here, na? Am I right?
Yes, sir.
Okay, so you're reading by prism, you are able to see here. So when you rotate, your magnetic needle will be stationary. Your outer circle of this instrument, if you see in the slide, the outer circle will move. Okay, you can see in the video also. Okay, so whatever the reading I am able to see. Okay, so I will see 30 degree or 180 degree here. Okay, so there is no need to do subtraction in prismatic compass. I hope you are getting the point.
Yes, sir. Yes, sir.
Yeah.
Understood.
Okay, you can see in the YouTube, or okay, if the more clarity, you have to make some effort because anyhow you should know. So my question is that what I said in the beginning, we are using the chain and prismatic compass. Chain for the linear measurement and prismatic compass for the magnetic bearing. So why I am using the chain? This is my question, because I have this measuring tape with me. Can I replace chain with measuring tape? Because only I'm using measuring tape to measure the offsets, nothing else. So why I'm not using measuring tape for the main chain length? Are you getting my question? Students? Hello?
Yes, I got the question.
Yeah, what I'm saying, I'm using the chain. Why not measuring tape for the main survey length? Why? Why it is so? Both can be used? Then
Sir, in measuring tape, we cannot place ranging rod, so there may be more error.
okay,
in measuring the rod.
more error, okay, but what can be the other way? Answer. More error.
Rigidity.
Because error will be there because list count is 20 centimeter now. Your chain has the length of 20 centimeter and your measuring tape has the list count of 1 mm. So I think measuring tape is more accurate. Can I say?
Sir, but in chain we can place ranging rods in between to make it straight, but in measuring tape we have
Okay,
few points.
okay. Again, I'm able to make the ranging rod. Then what can be the reason? Just think about it. Because everywhere, if you see, it is written the if I'm using the traversing open and close to make with chain and prismatic compass, you will never find the chain. It is written like that. Use the measuring tape. No, you cannot write. There is some technical reason. You think about it.
The
Okay, I'm
rigidity,
giving you 1 week time. Yeah, tell me.
in, rigidity in the chain, like it won't bend, so it won't give a
Yeah,
small.
it can be one of the reason. Okay, it can be. So I can use the steel tape. Okay, if this
Sir,
is so,
its length.
yeah, repeat.
Sir, about length.
Yeah. So what you are saying? Please complete your sentence.
The measuring tape can also get elongate after pulling.
That is also applicable to this chain. Okay. This is some technical reason. Okay. This is all are the you are saying me the operational difficulties. Okay. There's some technical reason. Just think about it. I think it's very
So
easy.
the chain needs to be tied to a ranging rod that we can't do always to a tree, like if we are finding some offset.
Repeat, please. What are you saying?
So like if we have to find an offset from a tree, then how can we tie the chain to the tree?
No. I want to only replace this chain with the measuring tape. Now I can use the two measuring tape. What is the issue? I'm taking the offset with the measuring tape, no issue. But why I'm using chain when I have the measuring tape which has the list count of 1 mm? Why I'm using 20 centimeter chain? It should be the question. No? Am I right? My
Sir, it
question
is
is
more
right?
flexible.
No. Just think technically. Okay, these all are operational things you're telling me. Okay, I'm giving you enough time. Just think about it.
Sir, we use whole to part technique to calculate area, so we have to connect in between stations, so we use chain.
No. It is not the way. Okay, think. We will discuss on the next class. So if any questions other than that, you can ask me.
Sir, I have a question related to CAD.
Anyone having any
Connecting multiple chains.
Yes.
Sir, do we have to include that CAD thing in experiment 2?
No, whatever data we will provide you by Monday, you have to plot. You have to make a map on a drawing sheet. Okay.
Yes,
So
sir.
any software you can do.
Yes, sir. That part, do we have to submit?
Yes.
Sir, in experiment 2 or in experiment 3?
No, it's experiment 2 now. You will submit
Sir,
in 2.
then what is the deadline for experiment 2?
That you will decide. Okay, don't worry.
So like if we will get the data points on Monday, then it's not easy to.
Why are you worrying? Why are you worry about it? Okay, I'm
Get
not.
sufficient time, no problem.
Yeah, we will give you the time. You can understand. Okay.
Yes, sir.
You haven't given the end time, na? Don't worry. I thinking Saurabh Raj, you will ask some technical question. Okay, anyone?
I request all of you, there are so many good videos related to prismatic compass survey. So for better understanding, you must visit all those YouTube videos.
That is always benefit. So,
Professor Patra, you have something to say?
Professor Patra, please.
No, I think it is pretty much done. I think unless they have any query, we are almost done. So I think you have already explained them very carefully, very slowly. So I think this is fine.
We need to have the TAs also included in this lab so that participating.
Yeah, that we will do when the institute will open, sir, because we have to make even meeting from them.
I think next week we'll decide. Actually, this week we had also planned for video recording. So those things we will all discuss once the institute opens next Monday. We need to plan again.
Yes.
Yeah. So for today, I think the class is nearly over unless they have any query.
Yeah. Sunita, madam, you have something?
No, sir. Think the class was done properly, so I don't have any. So just that when you are submitting, you want to submit, if you want to do it on a drawing sheet, then you can take the picture and upload the drawing sheet, and if you want to do it in AutoCAD, then you can don't upload the AutoCAD file, that is with .swsp file. It would be something like that, it would be created. So you just put a snapshot there and put your put your name on it, so that we'll get to know that you have drawn that. Okay, that's all.
No, what they should upload, we will tell them.
Yes, sir. That AutoCAD file they sometimes upload, so that we may not be.
That we can decide because the snapshot they can put on the PDF file.
Yes,
And
yes.
the AutoCAD drawing they can upload separately. So those is also.
That's what I meant.
Okay.
They export it as a PDF file or a JPG file and put their name on it. That will be sufficient. As you are being taught in, you have been taught in your engineering drawing, so you have to put your name, your roll number there, and then you can just upload it. Okay. Okay, so that's all from my side.
Very good. So, Kamlesh ji,
sir.
So lab कब खुलेगा? आप कब when will you be getting fit certificate? वो भी बहुत important.
Most probably from Monday, I will get my office order for joining.
Right. Okay, good. Okay, Monday we'll have some discussions and meeting for next few more labs, video recording and all. Okay, so good. Students, you have any further doubts, queries, questions to be asked? After you receive the data on Monday, then we decide. It will be coming with the deadline. So, yeah, don't worry about the deadlines now. So, other than that, any technical queries you have about the procedural components of conducting the lab, taking the records, maintaining the field book? Anything else? We can have it here now. Let me see the last student. Who is this? Vidya Siddharth. Siddharth, you are there? Siddharth? Siddharth, you're there?
Sir?
Okay, good. So you have followed everything?
Yes, sir.
Very good. Okay, so fine. So class leaders.
Yes, sir.
Okay, so we can end the lab for today. Okay. There is no other thing. Okay. So one link for uploading the assignment will be put. That will be having the deadline will be put after you receive the Monday's picture files of year before last or some old field notebooks. But for the first lab, whoever have uploaded, it's fine. Whoever haven't, you please upload quickly. And yeah, those 2 students, you stay back, others may leave. We will be all faculty involved. Please stay back. We can have some discussion with these 2 students. Is it clear?
Thank you, sir.
Okay. Bye.
Okay. Take care.
Thank you, sir.
Thank you, sir.
Rohit.
Thank you, sir.
Thank you, sir.
Rohit.
Thank you, sir.
And Swanjali and Ratlavat Abhiram, I think is not there.
3 of
Sir, I'm there.
Swanjali is there. Ratlavat Abhiram?
Rakesh ji, you can stop the recording.
Yeah.